Hello. Now let's look at learning rule number 2, which is memory-based learning rule. So in this case, in the case of memory-based learning rule, memory-based learning, so all memory-based learning, all or most of the past experiences are explicitly stored in a large memory of correctly classified input-output examples. So, for example, you have certain features which represent a certain city, for example, Rome. So we know that, okay, so this DI is the country, and XI corresponds to certain features, for example, the language spoken in that city, the type of food they eat, the culture, and all that number of features. So you have a set of pairs, XI and DI, n of them. So XI denotes an input vector, which is, for example, a feature vector, and DI denotes the corresponding desired response, which is, for example, the country. So when you want to classify a test vector X test, for example, Trento, which has not been seen before. So you compute all the features for Trento, the language, the culture, and a number of features which correspond to the culture and so on. You put them in a vector, and then you want to see whether it belongs to Italy or not. So when classification of a test vector X test not seen before is required, the algorithm responds by retrieving, so it's a retrieval approach, and analyzing the training data in a local neighborhood of X test. So it looks for Trento in that feature space, multidimensional feature space, and it looks for the local neighbor of X test. So all memory-based learning algorithms involve two essential ingredients which make them different from each other. So the first one is the criterion that is used to define the local neighborhood of X test. So for example, the nearest neighbor, the 5 nearest neighbors, and we're going to see some example, and the learning rule applied to the training examples in the local neighborhood of X test. So we'll explain that in a second. So the nearest neighbor rule, NNR. So you say that the vector X prime N belongs to a set, which belongs to a set of X1, X2, Xn, a set of N elements. So you say that X prime is the nearest neighbor of X test. So when I give you X test, you go and compute. So you say that X test is the nearest neighbor of Xn if the distance between X test and X prime is equal to, so you go, what you do, you go to X test and you compute the distance with all the Xi's, with all the elements in that set. And then you look for the minimum one. And that one, and the one, so if Xi, if you find that X prime, Xi equal X prime In, then you say that that's the nearest neighbor. So you say that X prime N is the class of X test. So that was the nearest neighbor. Now the K nearest neighbor. So for example, the 5 nearest neighbor or the 7 nearest neighbor. So K is an integer. So it can be, for example, 5. So K nearest neighbor rule, which is a variance of the nearest neighbor, you identify the K classified patterns that lie nearest to X test for some integer K. So you identify the 5, for example, for the K nearest neighborhood, 5 classified patterns which are nearest to X test. And you assign X test to the class that is most frequently represented in the K nearest neighbor to X test. We'll illustrate that in a second. So okay, so this is, yeah, we'll illustrate that in a second. So you have a number of networks, for example, radial basis function networks is a memory-based classifier, and then it is based on the, it is a memory-based classifier. So K nearest neighbor, let's look at an example. So the data is represented as a high dimensional vector. For example, you have 3 classes here, and for example, this is this corresponds to French cities. This corresponds to Italian cities. This corresponds to cities in Switzerland. But then these are not like, this is a feature space. So in this feature space, you have the elements of that vector, of that feature vector correspond, as I said, to the language they speak, to the type of food they eat, and so on. So a number of cultural features, for example. So to say that, okay, you want to, so you have an X test, and you want to check whether, to which city, so you have Trento, for example, which comes here, and then you want to see, is it closest in culture and all these things to cities in Italy, or cities in France, or something. So so you want a distance metric to measure the similarity between, in this feature space. You want the choice of K, for example, the 3 nearest neighbor to my query. And then you need a potentially a choice of elements weighting the vector. So you may weight the vector. So for example, you may say that language is more, should have more weight in my feature space. And so when you're given a new example, you compute the distances to each known example. So if your input is here, so you compute the distances to all these elements in your known examples, and you choose the class which is most popular. So for example, you have, this is my query, a new item. So what I do is I compute the distance to all my known, as I said, to all my known examples, maybe in that, okay. And then I pick the K best distances. So if I'm talking about 5, so in this case, it's the 5 nearest neighbor. So I pick the K, which the best distances. So I take the, so before I had all the distances, now I pick the 5 best distances, which are these ones, right? And then now my goal is to assign this black dot to, in this feature space, to the orange class or to the purple class. So I assign the class to a new example. I assign it to the orange because that's the most frequent one. So my dot, my query is closest to 1, 2, 3, 4 elements of that class compared to just one in the purple. So I assign it to this class here. So examples. So image search. So if I have a query image, and this image is represented by features like the color histogram, the texture moments, maybe some geometric features, okay? So what I do is I assign it to the closest. So my goal is to find the similarity search using these features. So for example, if I use the 10 nearest neighbors, so I want to find the 10 most similar images to the query image. So this is how I would do it, just like the K nearest neighbor. And these would be my outputs. Other examples or applications for web page search. So for example, I want to find the 100 most similar pages for a given page. So what I do is I do a representation of this page as word frequency vectors. So for example, I have a page, I look for the number of, or the frequency that a certain word comes in that page, or and then and then I look for my similarity would be the vector distance in that space. Same thing for the GIS, the Geographical Information System. I need to find the 5 closest cities to city Brisbane, which is a city in Australia. Okay, so same thing. So 5 nearest neighbor in this case. Thank you.